I've been on a reliability journey for a long time, and I developed a passion for reliability when I was in the U.S. Navy, and ended up in Navy weapons systems, and towards the end of my time, helped develop the Tomahawk cruise missile, the high-energy laser. And you realize how important reliability is when you're dealing with some of these weapons that have devastating consequences. You want to be over there when it blows up, not here. And so that's how I got a passion for it. And then individually, I just don't like it when things don't work. So every system you have is giving you what it's designed to give you. If you don't like the results, you need to go back and look at the system that you have. So if you look at maintenance, what is maintenance? It's defined as keeping something in its current state. It's maintaining its current state. That's what maintenance is and does. Reliability is the probability that something will perform its intended function for a designated period of time. What's the difference? Maintenance is reliability. Maintenance contributes to reliability. Reliability is maintenance. The question for you all to ask yourselves right now is, do you have a maintenance system or a reliability system? And I was in the maintenance trap for years and led world-class, benchmark world-class maintenance organizations. But that's what we did, was maintenance. So if a machine breaks down, who do you call? Maintenance, right? It's maintenance's fault. And so that doesn't do your customer any good if it's not working. And so maintenance can come, make it run again, but I stand that that's not maintenance, that's repair. There's a difference. Question you can ask yourself now is, how much unreliability are you willing to accept? So in your workplaces, how many of you go to your day job as kind of a hobby and you make your real money somewhere else? Anybody? If you didn't have your equipment at your day job, how much money would your company make? If you had to do it all manually, probably not very much, right? So your livelihood depends on the reliability of that system. Think about reliability of your car. How many days a week are you going to allow your car to strand you somewhere before you're going to do something about it? Is it okay for your car to just not start 2 days a week? You can do something about it? Is it a maintenance issue? Maybe not. Probably a reliability issue. So the other thing about unreliability is, if you look at some of the benchmark studies, and we'll get into it in just a little bit, there's a very strong correlation between reliability and safety. Most people are hurt when your equipment is unreliable, you're clearing jams and doing things like that. So now it's safety, now it's your livelihood. It's not life and death. It's a slow death, it's a slow spiral. Think about airplanes. How many times has a commercial airliner crashed twice for the same reason? Once. That 737 MAX, that sensor issue there, they had 2 crashes for the same reason. Every other airline crash, every other failure in there, if it happens once, they're going to fix it so it doesn't happen again. And if they didn't have that mindset, you never would have met me, because I flew here and I'm not going to get on an unreliable airplane. So what's the difference? If an airplane goes down, who knows about it? Everybody in the world. Next news cycle, bang, it's not more than 20 minutes before the whole world knows. If your machine breaks down, who knows about it? Well, if it's down a little while, maybe the supervisor, down a little longer, maybe the manager, maybe work its way up. That's your living. It's how you make your living. So we need to start taking reliability a little more seriously. And you can't have true reliability. I maintain, and again, I used to be a pure maintenance guy. And I've learned over the years that it takes proper operation, proper maintenance, and proper design for you to be reliable. It takes all 3. You can't get true reliability without all 3. There's a quote, one untrained operator can damage a machine faster than 10 maintenance people can fix it. It's true. Contamination, mislubrication, and misoperation are the top 3 downtime reasons. Now for the bad news. You all been waiting for this, right? over a long enough period of time, every failure you've ever had is going to happen again unless you've done something to mitigate it. Think about the sleepless nights, think about all the calls, think about driving in an icy road trying to get the machine running again. Think about all the air freight, think about having to pay the bills for all the overtime and everything like that. Well, guess what? It's going to happen again. That's the difference. You can maintain it and try to keep it from, you can stretch out the duration, but it's going to happen again unless you do something to prevent it. How many have seen this DIPF curve? It's public domain. Anybody who's been through CRL training has seen this. And what does the DIPF stand for? Design, installation, potential failure, and failure. And where do most people, most companies that aren't progressive with this, I've seen studies and conducted my own studies, and it costs 3 to 7 times as much to run a machine in that part of the curve as it does to get farther up the curve. So what do we want to do? Oh, we want to get into preventive. We want to do PMs. And Craig and I consult with companies and stuff. We need to get our PM squared away. Okay. If we just had good PMs, all right. Doesn't mean you're going to have good reliability. It'll be better than what you got, but it's not going to be good. And, well, but we need to get into predictive, and you hear a lot of talk about that. We're going to get into predictive and move farther up the curve, and that's good because you have, what, a lot more notice. You don't have to airship parts and stuff. You have more notice for things. And then you get up into precision, and when we get into failure curves, we'll talk about that. But what you want to get into is the design. So think about automobiles. You know, when I got my first car, you had to make sure you carried a dry rag with you because if you ever went through a big puddle of water, it'd take your distributor cap off and dry out your points and your condensers and your distributor cap, right? Or get condensation in it. How many know what a distributor cap is? It's a few. How about wheel bearings? Got to repack your front wheel bearings every 40, 50,000 miles, right? Cars still have wheel bearings? I think so. My vehicles now, I'm not sure where the spark plugs are. It's all covered up. Why? I used to change spark plugs every 10,000 miles to keep performance up, right? They recommend now every 100,000. What changed? They started looking at reliability. They started having new materials, better seals, better greases, better lubricants, and they started changing the design. They got after root cause of why they're having failure. And Toyota drove a lot of that with the Camry, but now pretty much everybody's doing it. So that's what we have to do, is we have to get all the way up into the design and take these failures out of our system. We have to understand what they are and get rid of them. And if you look at the failure patterns, here, these are classic, out of Nolan and Heap's classic failure patterns. And if you look on the upper left, that's the bathtub curve. Most people, you know, most bearings and things fit into that kind of failure curve. And the wear out, the middle one would be like tires and things you're driving along. And as they get older, they get thinner and they're more likely to fail, and eventually they will fail. Or fatigue would be things like tie rods, trunnion arms, things like that. And of the top, do those all look like things we would check on a PM? Yeah, and you'll say things like, especially like the wear out, you check the tread, you check the condition of your belts, you check stuff like that. Those are things you do on a PM inspection. Fatigue, I mean, you can do ultrasonic testing of the metals, non-destructive testing. Look at that box in the top. That accounts for 8 to 23% of your failures. Your whole PM system is going after 8 to 23% of your failures. Is that good enough? You look on the bottom, those are random failure patterns. And except for the lower right, you're just going to have to make things either redundancy or mistake-proof or things like that. The one on the lower right, you can do stuff about that. Where the high part of the curve is, you can do it by doing precision installation, doing laser alignments. You ultrasonically test your bearings to make sure they're the right bearings and are lubricated right. Jason can tell you about the Kaiser plant here on startup. Didn't have oil in one of the big gearboxes. Oops. So I've been up almost a week. Oh, shut down. Let's airship this gearbox in. Those things you can eliminate through maintenance practices, through predictive practices. So PMs and predictive maintenance take care of the 8 to 23%, and they're important. And there's a lot of them out there. I'm sure you have a lot of bearings and a lot of belts and a lot of drive components and things like that in your factories and things. And that's important. The number is high, but the percent of failure is low. The bottom is really what I'm here to talk about. Defect elimination. The only way you're going to get reliable is to eliminate the cause of these defects. You're going to replace your old wheel bearings with sealed bearings with good lubricant in them. You're going to replace your distributor cap with electronic ignition. You do the things that you've seen, or some of you have never seen them. You didn't get to play. You didn't get to learn about your car. You know where to put the gas in, right? So the only difference when you look at maintenance and PMs, and a lot of people think, well, we need more PMs. And if you work in an operations manager, I can't tell you how many times I've had, when I was a maintenance guy, I've had an operations manager say after a failure, I want a PM for that. You write a PM for that. Okay. If it's a random failure pattern, are we going to do it every 4 seconds? I want a PM for that light bulb. You can tell when an incandescent light bulb is going bad. You can put it on a Wheatstone bridge, and you can tell when the filament's getting weak. You can do that with your incandescent light bulbs? No. So the only difference, doing PMs doesn't change your failure curve. It just stretches it out. And like if this was a bearing, think about a bearing being lubricated on the top line versus one being unlubricated in the bottom line. You think it's going to last longer if it gets lubricated? Sure. Belts, tires, things like that, they're going to last longer if they're properly maintained, but it doesn't change the failure pattern. It just stretches it out. And so PMs, it's kind of a game for optimizing PMs. You want to get the most gazoutas from the least gazindas. So if you look at this vertical part of the curve, the lower left side is zero production. You can see production is the vertical axis, and the time you spend on PMs is the horizontal axis. And if you spend no time, over time, your machines are going to break down, and we're not doing anything to stop that. So you're not going to have any production. As you start doing a little bit of PM activity, start coming up, the slope comes up quick. If you just start basically tightening, checking alignment, and lubricating, your output comes up really quick. And what you're looking for is that point right there. You're looking to get the most out of the least in, and that's all you'll get out of maintenance. So of non-optimized PMs, if you haven't been through a PM optimization process, 30 to 50% of the steps in there are waste. You could literally stop doing them and you would see no difference in your reliability at all. Up to 25% of the steps cause problems. And about 25% actually add value. So examples of waste are, the PMs aren't based on a failure frequency. Well, that looks like a monthly. That's about a quarterly. Is that really how often it needs to be checked? You do PMs, you take the machine down, you do PMs, you don't find any problems. We call that waste. And you're not prepared for the job plan. You send somebody out on a PM job plan, they don't have the parts, they don't have all the drawings or the tools that they need for it, and you watch them running back and forth. And we have a tool we use called maintenance mapping, and it's literally that. If anybody's ever seen spaghetti charting, similar concept, and you just basically measure back and forth what's the skilled tradesperson doing. And you'll find I've seen them as low as less than 1% value added, more than 99% waste on a PM. And or a job plan crosses a break boundary, so we write all these big PMs, and here's a 36-hour PM. How many shifts of people? Well, 36 hours, that's 3 12-hour shifts, so we're going to work people 12 hours. And they're going to be right on top of their game after 12 hours, right? You know? And then we're going to do a handoff, and you pick back up where I left off, and I think I left off here, and I think the parts are over there. And so you never want to allow a maintenance activity, a PM, to cross a break boundary, or very, very seldom. Examples of problems: guards and switches not left in the right position after you get done with the PM. Incorrect reassembly. Infant mortality, replaced components. I mean, not every component might look new and shiny. It doesn't mean it's good. And that's where some of the technology helps you. You put in, I've seen people do PMs for replace all the bearings in this machine. Okay, if you're going to do that, make sure you do an ultrasound check of the bearings. Make sure they're good, because bearing follows the bathtub curve. It's just as likely to fail in the beginning as it is in the end. Job plans run over time, and the big one is the machines aren't left in a runnable state. So we've got operations and maintenance in most organizations, and maintenance takes the machine, and it was running. Maintenance takes the machine down, and we're going to do a PM, and it's a 4-hour PM. Operations is thinking, okay, I'm not going to be producing for 4 hours. Maintenance is thinking, I've got 4 hours of wrench time. So already you're coming up late just because you got to get everything out of there and get the machine up and running again. So now that makes the operations manager really love maintenance when they do maintenance for you, right? Yeah, you can't have my machine anymore. And so Ron Moore is a really smart guy. I really like him. And he's a consultant. And he asked the question, do you have too much PM in your reliability system? When are you the most likely to have an oil failure on your car? Assuming you don't run Baja and things like that. I mean, just normal use. When are you most likely to have an oil failure? Exactly, right after an oil change. You went in, the filter was good, and it was sealed, and you had oil in it, and when you took it in, and then did they get the drain plug back in? Did they get the little gasket on the drain plug? Did they get the oil filter in right? Was it a good oil filter? Did they put the right amount of the right oil in it? So, do no harm. If you look at safety and the correlation between safety, and I'm sure almost everybody has seen this, right? Anybody not seen this before? Been around 100 years. But if you look at how many serious or major injuries you have, they're always preceded by minor injuries and maybe property damage or things like that, or little events, near misses. It's 600 to 1, and that's a pretty good ratio. Well, how about if we transpose that over to reliability? It translates pretty darn well. So all these little minor defects that are out there, and they're everywhere, lead to idling and minor stoppages, little stops, and then some portion of those are going to go into breakdown, and some portion of those are going to go into catastrophic failure. So if we have a serious or major injury, or even a minor injury on safety, what do? We just clean up the blood and go back to work? That's what OSHA's here for. If that's what your company does, you may want to give them a call. No, you try to find out why it is. And if you're a plant manager, how many times is the company going to allow you to have an injury, a major injury, for the same reason? Well, let's get away with the first one because they believe that you're really going to do something. If you have a second one, yeah, maybe you better study this a little better, and okay, now we got the real solution. You have a third time, and your new plant manager will fix it. It's just not acceptable. We just don't tolerate it. So what if we viewed reliability like safety? What if our vision was repeat unplanned failures are unacceptable? It's not acceptable to keep having the same fault over and over again. It's not acceptable. Within 24 hours, we want to do a review. We want some kind of an action plan in place, and we want it fixed so that we don't ever see that one again. That's what most companies do with safety. If you have safety, something happens. But it's all about the mindset. It's all about beginning to develop the mindset or the culture for it. This is the golden key. This is the whole thing about reliability. Is developing the mindset in your workforce that all repeat unplanned failures are preventable. If you get to root cause of the first one and put in a solution, you won't have another one. I mean, an asteroid could fall on your factory or something, I guess, and break it. And the other thing key here is everyone is responsible for reliability. Who draws the paycheck off of your equipment? Your plant manager, your safety manager, your CEO, the operators, the maintenance people, everybody draws a paycheck. Everybody ought to have skin in the game for it. And this is out of a DuPont study. Winston Leday benchmarked this and did a really nice job with it. But if you look at failures, and we keep talking about it, just slap wore out. I hear that in the South a lot. It just plumb wore out. No, it didn't. You didn't grease it. You didn't install it properly. You damaged it when you put it in. It didn't just slap wear out. And I've heard different numbers, and I've talked to people from SKF and stuff. When I worked for Kimberly-Clark, and we have a lot of bearings, got a $24 billion asset base. Number one part that we buy is bearings. And SKF saying, maybe you want to do something with that. You realize that 80% of these bearings didn't wear out. They didn't reach their life. 80% of the bearings that you have in there, and it's our largest single maintenance expense, did not reach their design life. 80%. Wow. That's a lot. That's millions of dollars a year. Basic wear and tear, yes, things do wear out. Some things do. About 12% of them. And the work practices, 84% of the failures come from our work practices. And I'm not talking about just the skilled tradespeople in there. I'm talking about procurement, stores, management, your PM system. Some of it is skilled trades, but it's IT, the operations, the way that things are operated. We met the enemy and he's us. So we need to go after our work practices. And this is from Reliability Web. If you take the CRL class, you'll see, you'll actually get a copy of it with their material. But the 5 sources, the primary sources of defects. Raw materials and process inputs. If you start putting out-of-spec stuff in, it starts to trash your machine. Machine wasn't designed to run that. Operational discipline, that's a big one. Maintenance workmanship, and that's becoming a bigger issue all the time now. When I came up, there was apprenticeships. You were really showed the right way to do things. People invested in your training. You might have 2 or 3 years of education before they turn you loose on your own. Now it's, I changed my own bicycle tires, so can I have a job? People just aren't trained. They don't spend the time and money training them. And for those that are in skilled trades, bless you, thanks. It'll allow me to live out what little life I have left and keep getting my retirement check. For those that are even thinking about it, it's a great place to be, to go get training. And actually, Pro Services here has their academy, and I've vetted their material, and it's really good material. So if you're even thinking about it or know somebody who is, send them over there. Maintenance material and storage, and motors, storing motors. That's one. If you just take a 50-horse motor and put it on a shelf and leave it there, and then 10 years you need it, is it going to run as long as a good, brandy new one? Not if you haven't been rotating the shaft, not if you haven't been maintaining your spare motor that's not even in service. And then design, build, and install. And so the defects are anything that creates waste. It can come from anywhere. And a defect in your system. I'm a skilled trades person. I know I need this part. I've identified I need the part. I go through procurement, and I think that part's going to last a couple of weeks. I need you to get me one. Then procurement doesn't. If you're a skilled trades, what can you do? Say, I told you so. Did that do any good for the business? No. The defect came from whoever was supposed to order. It came from your ordering system. So these defects come from everywhere, and you need to look at it. If you're going to get reliable, every one of these will cause you problems. And there's some enemies out there that are moving to this mindset. The 2 biggest enemies. What's this an example of? Huh? Yeah, not my job. Who's responsible for reliability? Everybody. So it is your job. If there's something you can do. This one's actually a bigger enemy here. What is that? It's an Iceman. It's close enough. It's better than it used to be. Yeah, we got it fixed. It's stronger than it used to be. I put a 10 amp fuse in instead of a 7 amp. It won't blow as often. You know, it's not close enough. There's precision to this, and we need to understand that to make things really reliable. And you have to watch out for these people there and show them, kind of show them the error of their ways. And if you look here, the yellow box here, that's a defect tank. That's where all your defects come into. And then some of them go through that tank. They get above the pipe there, and they fall off into failure. Some of your defects fall off into failures there. What you want to do is on the top left line here, the material inputs. There's things you can do around that, like with autonomous care and center lining or set points and operator-driven reliability. They're the ones who see it the most. And look where your defects are coming from and start turning those valves down, start taking activities in those areas. And one good place to start is with clean to inspect. How many of you bought a car as a teenager? Anybody else? They gave you cars? I had to buy mine. And so you go look for a used car, and you find your used car, and you bring your new used car home. What's the first thing you do? Wash it, wax it, armor all it, sparkle it all up. How many of you found something when you did that you didn't notice when you were looking to purchase it? Detailing. I bought a car, didn't have a spare tire. Didn't feel very smart, but I was glad I found it in my driveway instead of on the freeway. That's the thinking behind this. Is you want to get down to that level of detail with your machines and detail them. And how many of you would buy a fully restored 68 Camaro convertible and give it to your kid as your first car? Oh. How about if you bought a kind of a junker 68 convertible Camaro and you did a frame-up restoration with your kid so they understand it and then give them the keys? You think it'll last longer then? Yeah, of course. They have ownership of it. They try to keep it that way. When you have a new car, first time you see a scratch, oh my God. And that's it. We give up. Before the scratch, yeah, you wax it, you do all kinds of stuff with it. Actually, it's not a new car anymore after you get a scratch. Your machines include the operators in bringing these machines up. And Craig and I just got done doing a workshop in South Dakota, and they were a little surprised by the number of defects we found, given that they thought it was a pretty good running machine. And they're still working to fix those defects. So that's what we need to do. Under operating discipline, on the maintenance, you've got AB, that's alignment and balancing. These little colored squares are elements of the uptime elements from Reliability Web. But alignment and balancing and lubrication, you've got people in here who can really help you with that. Lubrication isn't just two guys in a grease gun anymore. A lot more to it than that. A lot of science involved with it. And HECO's on the edge of motor lubrication for sure. I've seen a lot of motors destroyed by grease gun. But these things are individual, and I'm going to leave this presentation. You guys can have it. I don't care if you print it, want to send it out, but it's kind of hard to read the little things here. But break it down into bite-sized pieces. And the goal is to keep the defects, to stop them at root cause, at source, and not let the defect tank fill up. Because if it does, it's going to spill over into the failure tank. Anybody ever seen this 110-100 rule? It was originally written as a quality tool, but it transposes very well to maintenance reliability. If you fix something at design, you have a whole lot of options to do, and it's very low cost to put it in. If you get out to where you're installed, the cost to change starts really going up, and your options start going down. And if you wait till you're in production, if you have enough money, you can fix it. But it's really expensive. It's 100 times as much to fix it when you have it commissioned and in operation as it would have been if you'd taken care of it in design. So you need systems to do this, and I'm not trying to overwhelm you with this. There are a number of these things out there that are public domain. These are all of the elements that you need to be successful if you want to be truly world-class reliable. These are the things you really need. You start out with planned and go into proactive, and then you work on your organization and engineered reliability performance culture. And we're getting into a lot of condition monitoring. And there's Augury does all kinds of things. Come in, we'll put our sensors in, we'll tell you what's going on with your machine. You guys have some stuff, your predictive group, that same kind of thing. But what if your organization doesn't answer the phone when the system calls them and says, hey, this bearing's getting ready to go out? Is your organization set up to take advantage of this kind of stuff? Do you have the right mindset in your organization to fix it? Because these systems are getting spooky accurate, but they don't do you any good at all. They're really cool to look at, but they don't do you any good at all if your organization is not set up to take advantage of it. This is a different one, uptime elements. And again, this is, go on reliabilityweb.com. These are all individual blocks, and so it's breaking your reliability system, your asset management system, down into little bite-sized pieces. And there's a little booklet for each one of these explaining. Good organized approach to it. Here's a case study, an actual case study. Manufacturing excellence, this is from 2020. I wasn't allowed to have anything more reliable than that. And I am retired now, but I did get permission to use this one. So if you look, the first thing we did down there is set a vision. And all critical assets available operate when scheduled at designated speed, meeting all health, safety, quality standards, enabling the highest levels of performance, the lowest total cost delivered for 2024. This program started in 2016. It's going to take you a while to get there. The mission is to create a culture that constantly goes after defects and failures. And it's not acceptable. The failures are not acceptable to them. So working on that culture. And so what you do is you take your plan, you take the areas you want to work in, and you plot them out so that it's visible to everybody. And these things, this is for a division, but they're available on the website to anybody in the division. There's 14 plants there that are part of this. And you track it, and you figure, what am I going to work on this year? So you can see where those red bars came in. We're not going to work on everything all at once, but we want to lay it all out so we can put things in context. We don't want to miss anything. And so if you look in 2020, the asset management strategy and did equipment criticality ranking for all of the assets. We started out with a couple pilot plant. We're going to work on autonomous care, operate for reliability. We're going to work on failure elimination cycles. So it's a program that I developed with Kimberly Clark, but it's to get to root cause, to have a small team analyze these things and try to understand why the things are failing and eliminate the failure. And the PM down management, because we're spending too much time on PMs and not getting enough out of them. And then the MI and MBC, the MI is management infrastructure, MBC is the people's mindsets, behaviors, and capabilities. That's all the training. Are the people aware? Do they know what they're doing? And then that's what we need from the leaders down below. Now, when we started this, and I just did a check-in with the regional leader last week, their maintenance cost is down, total maintenance cost is down 50%. Say it again, total maintenance cost is down 50%. If you transpose that across the whole company, the company spends $630, $640 million a year in maintenance. Half of that. Whoa, big number. And we did it with global warming. In COVID with supply chain issues. Because we don't take excuses. There's reasons, but there's no excuse for not doing this. None. So if you look at the journey, you know, and if you're standing on the ground looking at that, well, that's what it looks like when you're on the ground. You go, ooh, that's a big climb. And when you're reactive, you can set up a stable base. There's a lot of ground that you can set up that's flat, relatively flat, move some boulders out of the way and build your house, and you can live there. It costs you a lot of money. The next step people want to get to planned maintenance. Planned is good. Now you're starting to go up the hill. If we can just get to planned, we're going to stay there. Well, you're not standing on a flat surface anymore, you're standing on an angle. And if you don't continually update your plan and continually update your PMs, what do you get? Like you don't have PMs. Does your equipment run the same number of hours, the same speed, same age? No, that changes over time. So you're on a slippery slope here, trying to keep it planned. Well, We better get to predictive. We just get to predictive, we'll be all right, we'll be good. Well, you're starting to get to the steeper part of the hill when you get there. You're going to just sit right on predictive? No. You can do condition monitoring of some of your advanced analytics, artificial intelligence. And you won't get up this hill without all of these pieces. They just help you get farther up the hill, but are you going to build your house on something at an angle like that? No, I want to be flat. So when you have the defect elimination culture, our organization goes after defects, and repeat unplanned failures are not acceptable. This is what it looks like on the top. Obviously, this was a different season than the other picture before, but when you get to the top of the peak, there's a big enough area you can build a pretty good house and live in it, and it's flat. So you are either, in my opinion, the only stable places to be is in reactive maintenance, fix when it breaks, or defect elimination. Those are the only stable places to be with this. It has a lot of challenges. I'm not here to BS anybody. It's a lot of work. I mean, it's with an 8-year plan. The one you just saw we're halfway through an 8-year plan, but it's sure paying big bucks. So your question now is are you going to follow? Blindly follow going through this stuff, or are you going to lead it? And it takes people to step up. It takes leaders to step up and make a difference. I was hired into Kimberly-Clark. I was one person out of the 58,000 employees that were there. And when I left, we had 97 certified reliability leaders. I was only an employee for 10 years. And we have these systems in place that they're continuing to move up. And if you watch LinkedIn, you don't see so much North America because we're North America. We don't have to listen to these people. The ones in Latin America do because they recognize their job. They value their jobs. Look at some of the articles and some of the things they're publishing on LinkedIn now. It's pretty amazing. So you're not in this journey alone. Take a look around. Introduce yourself to somebody you don't know. And what's interesting is try to find somebody from a different industry that you're in and compare notes on your problems. And you'll see we all have the same problems. We all need to do the same things to get out of these problems. And then seriously spend time with some of your vendors. I mean, these vendors have been pretty carefully vetted, and these are some of the best here to help you on your journey. So use them as a resource. And like Justin was saying, thank you for taking time out of your life to do this. Thank you for giving me part of your life. Make it worth something to you. Take some of this and go back and do something with it. One thing, just start with one thing, get good at it, and then pick another one. And then people that want to read, Winston LeDay has a book, Don't Just Fix It, Improve It. It's an easy read, about doing stuff. And then Making Common Sense, Common Practice by Ron Moore. A little tougher read, but it's a really good book. Tells you what to do. And then ReliabilityWeb, smrp.org, and Up to Your Reliability. We're here for you. HECO is a good place. If you're a HECO customer, good for you. You picked in my opinion, the best in the industry. So you're already way ahead of the curve using that. Take advantage of their knowledge.